prove that sin x plus a cosine x equals to b when x belongs to real number if and only if when a squared minus b squared plus 1 is greater and equal to 0. Basically, how to prove an equation with real roots has coefficients somehow greater and equals to 0. Wait, coefficients somehow greater than equals to 0 when there are real roots? Isn't it sounds like the quadratic equations and its discriminant? More specifically, the quadratic equation have real roots if and only if b squared minus 4ac is greater and equals to 0. Quadratic function always has one solution when discriminant is 0. When it goes to negative, the function does not have x-intercept, which means does not have real roots. Therefore, when discriminant is greater and equals to 0, the equation have at least one real solution. So let's try to organize the question into the form of standard quadratic equation and see whether the discriminant can solve the problem. Let me just leave the standard form down there, which is easier to compare. And in order to get a similar shape of quadratic equation, let's substitute sin x by y. So that cosine x due to Pythagorean theorem would be square root of 1 minus y squared. There is a little trick whenever you want to get rid of the square root. You want to put the square root thing as an individual in one side of equal sign and square both sides. After that, just normal expansion. Here we factor out the coefficient of quadratic term and the linear term. We are done. Now let's compare the standard quadratic form and our question. We have the orange variable. As you can see, it's y and x, but it's fine. Z is also okay. And the coefficient of quadratic term, the coefficient of linear term. Finally, our constant. Since discriminant is b squared minus 4ac, we have negative 2b squared minus 4 1 plus a squared times b squared minus a squared is greater and equals to 0. Now we factor 4 out, do some normal expansion. And we can cancel out b squared. As the second least step, we factor a out and rearrange the whole thing a little bit. A squared minus b squared plus 1 greater and equals to 0. QED.